Example 19.1 introduces the idea of an antiderivative. For most of calculus, a student spends their time finding derivatives of functions. So given a function f of x, in fact, I'm going to do this in blue. Given a function f of x, you can differentiate f of x, right? You can plug that function f into a derivative or into the derivative operator, and the derivative of it, right? The derivative of capital F of x with respect to x can give you maybe a function f of x, right? Now we're looking for something that undoes this. So now we're looking for this direction, starting with something that is a derivative and finding the antiderivative, i.e. finding the original function who has little f as a derivative. So example 19.1 wants us to take the function f of x, which is 3/2 x squared plus 3, and find an antiderivative. So I want to find a function, capital F, which when I differentiate it, I get back lowercase f. So here we're going to have rules that do this for us, but for now, let's try to intuitively think about it. This x squared right there, if I want a function to differentiate to be x squared, it should be x cubed. And this 3 right here, we'll worry about the constants in a minute. For the 3, you want a function whose derivative is equal to 3. So we should choose 3x. And let's check ourselves here. If we take f of x and we differentiate it, our goal is to end up at what we were given, lowercase f of x. And by differentiating this capital F function, we have 3x squared plus 3. So the plus 3 is correct, but the x squared term didn't give us what we thought we should get. We need an extra division by 2. All right, now let's check again. If f of x, capital F of x, is 1/2 x cubed plus 3x, then the derivative of capital F of x will then be 3/2 x squared plus 3. That is our original function. So capital F differentiated to lowercase f, which means that capital F is an antiderivative of lowercase f.